to another session. This session is specially dedicated to the understanding of a process statement. First of all, we know that the statements that are written in VHDL are executed concurrently by the compiler. What do we mean by that is that all the statements in a program, VHDL program, are taken all at a time and internally executed by the compiler itself. That means that we may not be able to design sequential circuits by default writing their code inside a VHDL architecture. So in order to do that, we need to dedicate a particular portion of the code, and that portion is called as process. In a process statement, whichever statements we write inside a process statement, they are executed one by one in a sequential manner. And that's how we implement sequential circuits or sequential machines using a process statement only. So when what is this process basically? It is a function which we use inside the architecture block, and it allows us for sequential statements or use of sequential statements. So it is always declared within the architecture block. So whenever you talk about a process is a statement that is used inside the architecture block. Okay. So multiple processes can be executed concurrently, but statements within the process are executed sequentially. What does this mean? अब imagine कीजिए आपके sequential circuits के दो तीन modules हैं. So if you want to write three processes inside the architecture, so एक process dedicate होगी एक part के लिए, दूसरी process दूसरे part के लिए, and तीसरी process तीसरे part के लिए. हालांकि कंपाइलर एट अ टाइम तीनों प्रोसेस को स्टार्ट करेगा एग्जीक्यूट करना, और उनके लेकिन अंदर जो स्टेप्स है उनको वन बाय वन एग्जीक्यूट करेगा. आप समझ रहे मेरी बात? So every process has a sequential flow of execution inside it, but every architecture has a concurrent flow of execution inside it. Remember this, please. So by default, VHDL architecture execution is concurrent, and if we want to design any sequential circuit using VHDL, for that we have to write a process. That's it. This is the crisp definition. Why do we need a process? VHDL by default or VHDL programming is concurrent. If we want to design a sequential circuit inside a VHDL program, we have to use a process. No other option is out there. Now, what does this process look like? You can always use a process name before going for a process. You can name it P1, and this process, all these blue colored words are keywords. So process is a keyword. Then you will have two brackets. Inside the brackets, you use a sensitivity list. Sensitivity list का मतलब ये है कि ये प्रोसेस कब एग्जीक्यूट होना शुरू होगी, वो डिटरमाइन होता है आपकी सेंसिटिविटी लिस्ट से. फॉर एग्जांपल, आपने एक फ्लिप फ्लॉप डिजाइन किया, और फ्लिप फ्लॉप शुरू होना चाहिए जब भी क्लॉक आए या इनपुट डी आए. तो सेंसिटिविटी लिस्ट के अंदर आप लिखेंगे clock comma d. Right? That means whenever your clock changes or whenever a new input comes to the flip flop, it will start the process. Or else, a simple way is to use d only, data. So whenever the new data comes, the process will start. Then you have the begin of the process, and you write your statement, whatever you want to do. Say you want to say assign a as 0, then this is 1 0, and so on, and process. So sensor list defines what a process is dependent upon list of signals in the system. That is, sensor list will contain the list of signals in the system. The process will execute when any of these signals changes. So this is an example of a process statement. Very briefly, we will just say it. This is the architecture, the main body of the architecture. These are some signals which are being described over here, signal A and signal B, or declared rather is the right word, because we do all the declaration before the begin of the architecture, and here it follows also. Now this 3 down to 0 means that this A variable is a vector type and has 4 bits. 3 down to 0. 2 down to 0 would have meant it has 3 bits. 1 down to 0, 2 bits. Okay. And when you want only 1 bit, you don't need to write it as vector. You will write SOD underscore logic only. So we come to know that these A and B are 4-bit data bits. Now we name this process as ABS. So ABS process A. That means when input A changes, only then this process will be started or executed. And if the input B changes, this process will not start. Please remember. That's why in sensory list we have only variable A. Now begin. If A is greater than 100, then B is assigned as not A plus 1. That is the complemented version of this plus 1. Else, if A is less than or equal to 0, 1, 1, 1, then that is less than 7 or equal to 7, then B is equal to A. Okay? Else, B is assigned as 0, 0, 0. For all other cases, B is assigned as 0. So this is just a simple and if and if. We have also used an if loop over here, but our main focus is the process. So I'm not kind of telling you to understand the logic of this program, but I'm just telling you to understand how a process is used. So just elaborate upon it further. A behavioral descriptions are supported with the process statements. The process statements can appear in the body of the articulation, just as the signal assignment statements does. The contents of process statements can include sequential statements. Make sure that we use process mostly for sequential design, but it does not mean if we use it for combinational design, we cannot use. We can also use a process for combinational design, which we will see in later examples. That we will use design logic gates using a process statement. Only difference by designing them using a process and a general program is that once they are designed using process, the execution is sequential. Okay. So these statements are used to compute the outputs of the process from its inputs. Fine. Sequential statements are often more powerful, but sometimes have no direct correspondence to the hardware implementation. The process statements can also contain signal assignments in order to specify the outputs of the process. So that's the end of the dedicated lab towards process. We will see now maybe the different designs of different basic circuits.